Thank you. And make it level. Okay, so can you see the top? I'll zoom out a little bit.
Yeah.
Yeah, I can. There we go. That's better, isn't it? So guys, today we're jumping ahead to 4D, right? We did 4A1, 4A2, and we're going to leave that aside for now. That was sort of lower and upper rectangles. And there's an exam question to have a go at in your notes book. I recommend having a go at that question. But what we're doing now is we're looking forward to 4D. The reason we're not going to do 4D is because it's clunky. And it gets you to think, and it gets you to think about this process, but I think it's better to just explain it rather than trying to think about it yourself. Because people get it's an exercise people get tripped up in. So in terms of, is it a necessary skill? No, it's not, because it's just introducing you to this idea that we're going to look at in 4D. 4C, we will come back and do 4C. The reason we're not doing it now is because I think it fits better with 4G, okay? So we're skipping 4B, not doing it at all. 4C we'll do later. And we're on to 4D because it sort of explains the content of 4B. So here's what integration is about. This is sort of the pinnacle of this next unit. And so we're familiar with calculus, right, where we differentiate. We have some function and we perform differentiation, that's the process, and that gives us the derivative function, okay? What we're doing now is we're starting with the derivative function and we're going back the other way. We're saying, what is it that we differentiated in order to get this function? Okay, and that process is called integration, sometimes called anti-differentiation, and this is the symbol that we use to show we're performing the antiderivative of something. Okay, so we're familiar with going this way. We start with a function and we differentiate it and we get a derivative function. All right, now we're going to do the opposite, where we start with a derivative and we're going to say, what did we differentiate to get? So let's just look at this quickly. Like, we know if I differentiate the function x squared, all right, if I differentiate that, I'm going to get 2x. Okay, if I differentiate x squared, I'm going to get 2x, which means if I integrate 2x, I'm going to get x squared. Okay, so that's all we're doing. We're going to start with differentiation and make a connection to the integration. So let's have a look at the first problem. It says, differentiate this function. All right, so this is, we're just going to use the power rule, we'll go through. So what this means, d on dx, it means the derivative of what's in brackets with regards to x. Okay, process that. So we're going to have 4x to the power of 3 takes 6x. All right, that's what the derivative is. Okay, so it says, differentiate this, hence find the integral. Okay, so we know if we differentiate this, this is what we obtain. Therefore, if we integrate this, okay, we're always integrating with regards to x, all right? So it's the integral of this function, the antiderivative of this function with regards to x, it's going to be this one here. Plus c. Okay, now the reason we put on plus c, all right, the reason we put on plus c, remember that circumstance over here, I was saying if I have x squared plus, let's go 5, and I differentiate this, we get 2x. The constant disappears, right? And so the reason we always put plus c is because we're anticipating there may be some constant that we can't arrive at through this integration process. All right, so whenever you perform an integral, it's what it is, and then plus c, tack that on the end. All right, let's move on to the next one. We've got the derivative of, so it says find d on dx of cos of 3x. Okay, find d on dx of cos of 3x. So you might have to have a look at your calculus notebooks. So when you differentiate a cos of f of x function, it goes to minus f dash of x sine of f of x. So it's going to be minus 3 sine of 3x. All right, when you differentiate this, this is what you obtain. Therefore, okay, therefore, if you integrate this function, this is what you obtain. Okay, so we're just making derivative statements to integral statements, right? So if we differentiate this, this is what we obtain. Therefore, the antiderivative of this, the antiderivative, if you're going back the other way, this is what it's going to be. Now look at the question. It doesn't ask the antiderivative of minus 3 sine 3x. Rather, it asks for the antiderivative of just the sine 3x. We've got to get rid of this minus 3. And that's as simple as we can just pull that out the front of this integral. So that's one of the properties that we're going to see. I can express it like this. All right, minus 3 is a number. Any product can be pulled out the front. And so that's going to equal cos of 3x. And what I'm trying to do, this is an equation, right? I've got this part is equal to this part. I'm trying to isolate this component. So I'm going to divide both sides by minus 3 so that it will cancel. All right, I'm going to divide by minus 3 and then divide by minus 3. It's going to cancel over here. So we'll have integral of sine 3x, I hope you guys can see, and this is negative a third of cos 3x. Okay, so what do we do? We're saying if you differentiate this, this is what you obtain. So then we made the integral statement, and then we're processing it until we get the part that the question wants by itself. All right, now one way you can check plus c, don't forget plus c. One way you can check, what we're saying is the antiderivative of this, if you integrate this, this is what you obtain. Well, how do you check? Therefore, if you differentiate this whole thing, then that's what you obtain. Okay, that's the relationship, right? If the integral of this is this, therefore the derivative of this one is going to be this. Okay, and last one, number 3, we've got find d on dx of x squared take 3x to the power of 4. All right, so we're differentiating what's in the brackets there. Now we have to use the chain rule here. So it's going to be n f of x to the n take 1 multiplied by f dash of x. Okay, so if we differentiate this top function, this is what we obtain. This is the derivative. Therefore, the integral of 4 times x squared take 3x to the power of 3 times 3x take 3 with regards to x. If you integrate this function, this is what we obtain. All right, so we differentiate, done. Then we make an integral statement. The integral of this one has to be this one. And then we're looking at the question, we're going, what does it want me to find the integral of? It wants pretty much the same thing except without the 4. All right, we're looking along there. The order of multiplication doesn't matter, so that's the same. We just need to get rid of the 4. So we can pull the 4 out the front. And then divide both sides by 4, or multiply by 4, right? So the integral of x squared take 3x to the power of 3, times 2x take 3, with regards to x, it's a quarter of plus c. Alright, so what's the process for these problems? You differentiate, you make an integral statement, and then you manipulate it, if necessary, to isolate the part of the function that it is interested in. So let's have a go at that exercise. Is it making a bit of sense, what we're doing? Just the opposite to differentiation. Let's give it a go.